Welcome to our next lesson, which is solving quadratic inequalities with one variable. So a quadratic inequality in one variable can be written in general form, which is ax squared plus bx plus c, an inequality sign, so one of the four, then 0. So a, b, and c are real numbers, and a cannot be 0, or else we won't have a quadratic anymore. So your quadratic inequalities can be solved graphically or algebraically. The solution set to a quadratic inequality one variable can have no values, one value, or an infinite number of values. So there are 3 different types of answers we can have. We're going to use a series of steps to help us solve for this algebraically. So the first step is to solve the related equation. So we're going to use what we learned in quadratics in the last unit, which is either factor to solve for the equation, use a quadratic formula to solve the equation, or even complete the square to solve for the equation. And then we want to plot those points on a number line. When you plot the points, consider if it's an open or closed circle depending on your inequality. And these points that we have solved for in part A, the first part, is called the critical points. So all the x-intercepts are called the critical points. Then after, we're going to use test intervals to find the solution, or a sign analysis to find the solution. Okay, so we're going to use steps 1, 2, and 3 here to do our example number 1. The first thing we want to do is solve the related equation. So step 1 is to factor and solve. So x squared minus 2x minus 3 is the same thing as saying 3 times 1, because those are the factors of 3. And we want to create a negative 2 through addition here. If we had a negative 3 and a positive 1, we can do that. So our points then are going to be 3 and negative 1 once we solve for that. The next thing we're going to do is plot those points on a number line. So we have negative 1 and 3. We're going to create closed circles around negative 1 and 3 because we have a smaller than or equal to sign. Note that negative 1 and 3 are also critical points. So as a side note here, I'm going to say closed point for the smaller than or equal to sign. Step 3, we're going to use test intervals to find the solution or a sign analysis. So there are 3 intervals we need to consider. Negative infinity to negative 1, negative 1 to 3 is the other interval, and then from 3 to infinity. These are coming from our number line. So those are our 3 intervals we're going to consider. To figure out the sign and whether this inequality is true or not, I am going to plug in a point or an x value into our inequality that was given to us to see if it's true or not. If it's true, it's part of our solution. If it's not true, then it's not part of the solution. So from negative infinity to negative 1, we can pick any number. Let's just say negative 2. And we're going to put it into maybe the factored form of our inequality. So that would be negative 2 minus 3 times negative 2 plus 1. And this is supposed to be smaller than 0. If I did this calculation, I'm going to get negative 5 times negative 1, which is 6. Is this smaller or equal to 0? No, it's not. So that means negative infinity to negative 1 is not part of our solution. Now we're going to check between negative 1 and 3. I'm just going to pick x equals 0 because that falls in there, and put it into our factored form of our quadratic. So that is going to be 0 minus 3 0 plus 1, which is negative 3 times 1, which is negative 3. Is this smaller or equal to 0? Yes. So that means this is part of our solution set. And then lastly, let's check from 3 to infinity. We can pick 4, because that's between 3 to infinity. And then we'll put this in to our factored form. This is going to be a 1 times 5, which is 5. Is this smaller or equal to 0? No. So therefore, our solution set is going to be from negative 1 to. So note that if the inequality is smaller than or equal to or greater than or equal to, the critical points must be included, which is why I have square brackets. If you wanted to write this in set notation, this is how you would do it. It would be from negative 1 is smaller or equal to x, which is smaller or equal to 3. So one of those two answers in either interval notation or set notation is fine. Here's example 2. Same sort of thing. We want to solve for our equation. So that's negative x squared plus x plus 12 is equal to 0. I'm going to factor out the negative first. And then, looking at factors of 12, we can use 3 and 4. And we want to create a negative 1 with that, because that is the coefficient of the x. And we can have that if we had a negative 4 plus 3. So that means our x is negative 3, and our other x is 4. The second thing I'm going to do is plot this on the number line. I'm going to create open circles around our critical points because we are not including our critical points. We have a just strictly smaller than sign there. Step 3, I'm going to find if the inequality is true in each interval or not. That's a 1. This is the second interval. And this is the third interval. So let's just pick any value between negative infinity to negative 3. That could be negative 4. And I'm going to put it into the factored form from number 1 and see if this inequality is true or not. And we need to see if this is smaller than 0. Okay, so we are going to get negative 1, negative 8. So overall, we're going to get negative 8. This is certainly true, so that's part of our solution set. Now let's check between negative 3 and 4. Let's just use x equals 0. We're going to get 0 plus 3, 0 minus 4. So that's positive because we have a negative times a negative, and our overall answer is 12. Is this smaller than 0? No. So that is not part of our solution set. Lastly, we have our interval from 4 to infinity. Let's pick 5. Put it into our factored form of our inequality would be 5 plus 3, 5 minus 4, and hopefully that's smaller than 0. We're going to get negative 8, which is clearly smaller than 0, so that is a part of our solution set. So we're going to color that in on our number line. That's the graph of our solution set. And if I want to state as a final answer, it's going to be from negative infinity to negative 3, and 4 to infinity. The U just means and. You could also state this as an inequality. So we can say that x is smaller than negative 3, and x is greater than 4. Let's look at another example. If you try to factor this, you're going to find out that this is actually not factorable. So we will use the quadratic equation. I'm going to rewrite this so I can see what my A, B, and C values are. So just move the 12 to the other side. My A is 2, our B is -7, our C is -12. So that's our quadratic equation here. Now we want to simplify. -7 squared is 49. 2 times 12 is 24. Times by 4 is 96. And this is going to be positive 96 because we have a negative times a negative. Let's simplify the inside. It's 145. And then we can also get this into decimal, which is 4.76 and -1.26. Our second step is to create the diagram for this on the number line. Notice when I draw the number line, I'm not drawing super accurately. I'm just doing this so we have a good idea of where our solutions are going to lie. We are going to have an open circle around our critical points because we are not including it according to our inequality. Now the three intervals we're going to look at is from -infinity to -1.26. We also have -1.26 and 4.76 and 4.76 to infinity. So looking for the first value, or the first interval, we can pick x is equal to, let's just say -2. I'm going to put this right back into the original inequality. So that's going to be 2 times -2 squared minus 7 times -2 minus 12, and maybe this is greater than 0, and we're going to check. We're going to have 2 times 4 plus 14 minus 12. So obviously this is going to be a positive number here, which means that our inequality is satisfied. And I'm just not finding the final answer because honestly the numerical answer is irrelevant. We just care about the sign. So if this is greater than 0, we know it has to be positive. For the next one, I can just plug in x equals 0. Then we're going to get 2 times 0 squared minus 7 times 0 is maybe greater than 12. That means 0 is greater than 12, and that is not true. Lastly, we can pick 5. Okay, so that's 2 times 25 minus 35 minus 12. 2 times 25 is 50 minus 35 minus 12. This is still a positive number. You have 50 minus 35, which is 15 minus 12, which is 3, and this is clearly greater than 0, so we are good. That means this is our solution set. Just coloring it in our number line. Our final answer is going to be from -infinity to -1.26 and 4.76 to infinity, or you can state that x is smaller than -1.26 and x is greater than 4.76. You could also write our radical over here. If we keep the radical of the root of 145, we will get a more accurate answer. So you could also state your answer instead of -1.26 as 7 minus the root of 145 over 4, if you wanted to. Moving on to example 4. For this one, I'm going to try to solve for this by expanding, which is going to be 2 times x squared and 2 times negative 6, so 2x squared minus 12. I'm going to move everything to one side, and then factor. It's the method you're going to use, up to you. You can use the box method, which is factors of the coefficient of x squared, which is 2 and 1, and then factors of 12, which we can use is 3 and 4. So 2 times 4, I'm going to cross multiply to get the middle term. 2 times 4 is 8. 3 times 1 is 3. Now we want a 5. We can get this if we had, so we want a negative 5. To get this, we want a negative 8 and a positive 3. Double signs reflect just above, and this is what we're putting inside our brackets. So we have 2x plus 3 and x minus 4. So that means our x values will be negative 3 over 2 and 4. Now we're going to draw the number line. So our intervals are going to be from negative infinity to negative 3 over 2, negative 3 over 2 to 4, and then 4 to infinity. We're going to draw a closed-in circle around those two intercepts because of our inequality sign is the greater than or equal to. Okay, now we're going to find test points to make sure our inequalities remain true. So let's pick x equals maybe negative 2 for this one. I can put it into our factored form. Just make sure you have the correct inequality when you do that. So that's 2 times negative 2 plus 3 in one set of brackets, negative 2 minus 4 in the other set of brackets. We want to make sure that this is smaller than 0. So if we calculate this, we're going to get negative 6, and the other one's negative 4 plus 3, which is positive 6. And this is a no. So that's not a part of our solution set. Now let's look at our next interval. Let's use x equals 0. That's 2 times 0 plus 3, 0 minus 4. That's 3 times negative 4 is negative 12. And this is certainly true. 0 is greater than negative 12. Lastly, let's just use x equals 5. So you have 2 times negative 5 plus 3, negative 5 minus 4. This is going to be 13. Is this smaller than 0? No, not going to work. So this is our only solution set. We're going to go from negative 3 over 2 to 4 as our final answer. Or you can say it's negative 3 over 2, which is smaller than or equal to x, which is smaller or equal to 4. Again, if you look at the interval notation, remember to make square brackets because we are including 4 and negative 3 over 2. One more example, and this one is a word poem question. So if a baseball is thrown at an initial speed of 15 meters per second from a height of 2 meters above the ground, the inequality modeled by the time, t in seconds, that the baseball is in flight. We want to know what time interval is the baseball in flight. So we're looking for t. We're going to use the same method as before because we want the time interval of t. Just by looking at our inequality, we will have to use our quadratic equation. So our a is going to be negative 4.9, b is going to be 15, and c is going to be 2. Then we want to simplify this. We will use our calculator to help us out because we have decimal places here. 4 times 4.9 times 2 is 39.2. Negative times negative is a positive. Taking the square root of 225 plus 39.2 is 16.25423. And then we're going to simplify this to just two answers. We're going to get negative 0.128 and positive 3.189. Now we're going to put these on the number line. There's going to be open circles around those two because we are not including them according to our inequality. Now we're going to look at the time interval. Now our time interval cannot be negative, so it doesn't make sense for us to insert anything in here because time is negative here. So we don't even need to consider this one. And from here, same thing, time can't be negative, so we're going to actually start at 0 instead of our critical point, because it wouldn't make sense for us to have negative time. So we're going to look between 0 and 3.189. Notice that I use a closed bracket on the 0 because that is a point that's included between negative 0.128 and 3.189. But we cannot include the critical points. So if 0 can be included, we can just put 0 back into our inequality to see if it's true. That's 0 plus 0 plus 2. Is this greater than 0? Yes. So that means we can include from 0 to 3.189. Now we can pick a number greater than 3.189. Let's say t is 4. And see if this is true. You may use your calculator to see what this is, but you're going to find that this is going to be a negative number. So this would be a no. This will be our only answer in here. So your final answer is 0 to 3.189, not including 3.189. Or you can say it as 0 is smaller or equal to t, which is smaller than 3.18.